All right, so we've covered the foundation. AI finds patterns in data, and we've explored large language models, the AI that can chat, write, and reason with words. But here is the question that might be bugging you. How does AI actually learn these patterns? Like we keep saying, the AI learned this, or it was trained on that. But what does that actually mean? Today, we're pulling back the curtain on machine learning, the process that teaches AI, and we'll break down algorithms, the actual recipes AI follows to learn. By the end of the segment, you'll understand not just what AI does, but how it gets smart in the first place. Think of this as understanding the gym workout that makes AI strong. Let's dive in. Let's start simple. Machine learning is when we give a computer examples and let it figure out the patterns on its own instead of programming every single rule. Think about how you learn to ride a bike. Nobody gave you a 500-page manual with physics equations. You just tried it, fell, adjusted, tried again. Eventually, your brain figured out the pattern of balance. Machine learning works similarly. Show the computer examples, data, let it make mistakes, help it adjust, and repeat until it gets good. The magic word here is learning from experience, not from explicit instructions. Let's do a quick comparison. Traditional programming involves human written rules, which computer follow. Machine learning involves human provided data that computer discovers eventually. Not all learning is the same. Machine learning comes in three flavors. Supervised learning, learning with a teacher. This is like learning with flashcards. You show the AI an input and the correct answer. Examples: pictures of cats labeled cat, pictures of dogs labeled dog. The AI learns to match patterns to labels. Unsupervised learning, learning by exploring. This is like organizing your messy room without instructions. The AI finds patterns without labels. Example: grouping customers by shopping behavior. The AI discovers hidden structures in the data. Third is reinforcement learning, learning by doing. This is like learning a new video game. The AI tries things and gets rewards or penalties. Example: AI learning chess by playing millions of games. The AI figures out strategies through trial and error. Most of today's powerful AI uses supervised learning. That's how Gemini, ChatGPT, image classifiers, and recommendation systems work. Now let's talk about algorithms. An algorithm is just a step-by-step recipe for solving a problem, like a cooking recipe, but for math. In machine learning, algorithms are specific methods AI use to find patterns. Here are the superstars. Neural networks, the brain-inspired one. Remember from segment 1? Layers of artificial neurons, best for complex patterns like images, speech, language. Decision trees, the 20 questions one, makes decisions by asking yes or no questions. Is it bigger than a bread box? Is it alive? Answer: best for clear, explainable decisions. Linear regression, the line drawing one, finds the best straight line through data points, like drawing a trend line on a graph. Best for predicting numbers like prices, temperatures, scores. Key nearest neighbors, the friend group one, classifies things based on what's nearby. You are who you hang out with. Best for simple classification when similar things cluster together. Each algorithm has its superpower. The art is knowing which one to use when. All right, Let's peek inside the actual training process. This is where the magic happens. Step 1. Feed the data. The AI gets thousands or millions of examples, like showing a kid 10,000 pictures of animals. Step 2. Make a prediction. The AI guesses. At first, it's terrible. That elephant is definitely a mouse, it says. Step 3. Calculate the error. We measure how wrong the AI was. This is called the loss or cost. Step 4. Adjust the model. Here is the clever bit. The AI tweaks its internal parameters to be less wrong next time, like adjusting your aim after missing a basketball shot. Step 5. Repeat. Do this million of times. Each cycle is called an epoch. This whole process, it's called training. And it's basically high-speed trial and error with math. Now, a mini analogy. Imagine you're learning to throw darts. Throw is predict. See where it lands is error. Adjust your stance, your angle, update, and throw again. After 10,000 throws, you're pretty good. Here is why ML is revolutionary. It finds patterns humans can't see, detecting disease in X-rays before symptoms appear, spotting fraud in millions of transactions, predicting equipment failures before even they happen. It handles massive scale. Humans can review maybe 100 applications per day. ML can process millions in minutes. And it keeps improving. More data means better performance. It never forgets what it learned. It can update with new patterns. And it works 24x7. No coffee breaks, no sick days, and consistent performance. But remember, it's not magic. It's pattern recognition at a massive scale. Time for some real talk. Machine learning isn't perfect. The data problem. Garbage in, garbage out. If you train on biased data, you get biased AI. If you train on messy data, you get confused AI. Example, AI trained mostly on light-skinned faces struggles with darker skin tones. The black box problem. Sometimes we don't know why the AI made a decision. Neural networks can have billions of parameters, too complex for humans to interpret. For example, a problem appears when AI declines your loan, but we don't know why. The overfitting problem. Sometimes AI memorizes instead of learning, like memorizing test answers without understanding. Works great on training data, fails on the new data. That's why we always test on fresh data. The resource problem. Training advanced AI requires massive amounts of data. Powerful computers, very expensive. Lots of electricity. And times, weeks or months for big models. Let's make this concrete. Where do you encounter machine learning daily? Your phone camera, like face detection. Machine learning finds faces in the frame, like portrait mode. ML separates foreground and the background in your photos. The night mode, ML enhances the dark photos. Streaming services like Netflix recommendations, ML analyzes your viewing patterns. Spotify Discover Weekly, ML finds patterns in your music taste. And the YouTube algorithm, ML predicts what keeps you watching. Online shopping. Customers also bought, ML finds purchase patterns. Fraud detection, ML spots unusual transactions. Price optimization, ML adjusts prices based on demand. Healthcare, disease detection, ML spots patterns in medical images. Drug discovery, ML predicts molecular interaction. Treatment planning, ML recommends personalized therapies. You're literally surrounded by machine learning decisions. Let's crystallize what we have learned. Machine learning. Computers learning patterns from examples and not explicit rules. There are three types of machine learning: supervised with labels, unsupervised without labels, and reinforcement, trial and error. Algorithms are the recipes for learning: neural networks, decision trees, etc. Training is feeding the data into the model, predicting, and then measure error to adjust and then repeating it. ML is powerful because it finds hidden patterns at massive scale. Challenges include biased data, black boxes, overfitting, and resources. You interact with machine learning dozens of times daily without even realizing it. So now you understand the engine under the hood. You know how AI actually learns through algorithms, training, and lots of math-powered trial and error. But here is the thing. Knowing how AI learns is one thing. Actually getting it to do what you want, that's an art form. In our next segment, we're going to master that art. We'll learn prompt engineering, how to speak AI's language and get amazing results. Because the difference between meh AI results and wow AI output, it's all in how you ask. Ready to become an AI whisperer? Let's go to segment 4.